Differentiation 1, Rule 4, Chain Rule. So one of the questions for homework was question 8, part 5. So somebody has asked for this solution to be done out. So we are given here in this question y equals 1 over the square root of x squared plus 7x. So before we can differentiate this, we need to write it as x to a power. Okay, so because it's 1 over, that's instantly going to be to the power of minus. And then it's the square root of x squared plus 7. So therefore the square root is always to the power of a half. So that's going to be x squared plus 7x to the power of a half. But because it's 1 over, it's going to be to the power of minus a half. So now we're ready to differentiate. So this is our chain rule, where we're going to bring down the power, take 1 away from the power. So minus 1 minus a half is minus 3 over 2. And then we also have to multiply by the derivative of what's inside the brackets differentiated. So in other words, the function within the function. So the function inside there is x squared plus 7x. So if I differentiate x squared plus 7x, that gives me 2x plus 7. And technically that is our answer, but of course we can tidy it up a little bit by multiplying the minus a half by the 2x plus 7. And then that gives us dy dx is equal to minus 2x plus 7 over 2. And then I can write the minus as 1 over. And then the 3 over 2. The 3 is the power and 2 is the root. So that's the square root of x squared plus 7x in brackets to be cubed. So for my final line, then I would write that as minus 2x plus 7 all over 2 times the square root of x squared plus 7x in brackets cubed. Okay. Now I think there might have been a mistake there in the back of the book. For some reason they had differentiated x squared plus 7x. Instead of saying 2x plus 7, they've written it as 2x, I can see here. So that might have been what caused an issue when people were checking out their answers. Okay. So the second question then that was caused a bit of difficulty was question 11. So for question 11, we have to find the equation of the tangent t1 to the graph of f of x at the point 1, 1. And f of x we're given a graph of is the red line here, okay? So if we take our function f of x is equal to 2 minus x squared to the power of 5, then what we want to do is differentiate. So again, chain rule, so we're going to bring down the power, take 1 away from the power, multiplied by what's inside the brackets differentiated. So if I differentiate 2, I get 0, and if I differentiate minus x squared, I get minus 2x. So if I just tidy that up a bit, 5 times minus 2x is minus 10x, times 2 minus x squared to the power of 4. So what I want to do next then is look for the equation of the tangent, which means I need the slope. And remember, your derivative f dash x is equal to the slope of the tangent to the curve. And we have to find the slope at the point 1, 1. So that means x is y and y is 1. So we basically let x equal 1, and that will find me my slope. So that's going to be minus 10 times 1 times 2 minus 1 squared to the power of 4. So that's minus 10 times 2 minus 1, which is 1, and 1 to the power of 4 is just 1. So in other words, our slope is minus 10. So now I know what my slope is. I need the equation of the tangent. And of course, before I can find the equation of the tangent, I need the formula, which is, of course, y minus y1 equals m times x minus x1. and our point is 1, 1, and the slope is minus 10. So therefore that's x1 and y1 that we are going to sub in. So we have y minus 1 equals minus 10 times x minus 1, which is minus 10x plus 10. And therefore the equation of the tangent is 10x plus y minus 11 equals 0. So that's the equation of the tangent. Okay, so that's part 1. Now part 2 says that g of x, the green line, is the image of f of x by a horizontal translation, where that horizontal translation is given by 2 minus x plus a to be squared to the power of 5 for some constant a, and we have to find the value of a. Now if we look at the graphs there, and say I just pick this point here on my graph, let me mark it in yellow, then what we have is this point here on my graph is out to 0 up to just above 3 there. And if you look at the corresponding point, well, what have I done? I've shifted my graph 1 unit to the left. So because it's shifted 1 unit to the left, then that means that our translation is x plus a, where a is going to be 1. So in other words, g of x is equal to 2 minus x plus 1 squared to the power of 5. In other words, a equals 1. So the third part then says if t is parallel to t1, find the equation of t2. Now the fact that t2 is parallel to t1 tells us that they have to have the same slope. So therefore we can say the slope of t1 must equal the slope of t2, which we found out is minus 10. And we know that because t1 is parallel to t2 and g of x has been shifted 1 unit to the left, well then that means that the corresponding point, if we go back to the question, if we look at part 2, it said find the equation of the tangent t1 at the point 1, 1. Well, if g of x is the f of x graph shifted by 1 unit to the left, then that means this point 1, 1 has also shifted 1 unit to the left. In other words, this point here on my graph, if we look at it, I've marked it in red. Well, it was 1, 1, and if it's shifted 1 unit to the left, well, that must be 0, 1. So now what we have to do is find the equation of the tangent, same as we always do. Y minus y1 equals m times x minus x1, where we have 0, 1, and m is equal to minus 10. So we have x1, y1. So that gives us y minus 1 equals minus 10 times x minus 0, which is y minus 1 equals minus 10x. So therefore the equation of the tangent at 0, 1 for g of x is going to be 10x plus y minus 1 is equal to 0. Okay, so part 4 then says find the distance between t1 and t2. So if we want to find the distance between two parallel lines, well, we normally get the perpendicular distance. And our perpendicular distance formula is a times x1, b times y1 plus c all over the square root of a squared plus b squared. So this question is a really nice revision for our coordinate geometry of the line. So of course we pick one of our equations, and we find a point on the other line. So if we were to take the equation of the first line, t1, where we said that that was 10x plus y minus 11 equals 0. Sorry. So we have 10x plus y minus 11 equals 0. And then if we take a point on the other line, so that's basically t1. And if I take t2, that means I need a point on the line so that I can find the perpendicular distance. So the point on the line we said was 0, 1. So that's going to be our x1, y1. A is going to be 10, B is going to be 1, and C is going to be minus 11. So if we sub it into our formula, our perpendicular distance then is A, which is 10, times x1, which is 0, plus B, which is 1, times y1, which is 1, plus C, which is minus 11. And that's all over the square root of A squared plus B squared. So if I sub in, then I end up with 1 minus 11, which is minus 10 on the top, and the square root of 101. And of course then that can be written as 10 root 101 over 101. Or you can keep it as 10 over the square root of 101. Okay, so part 5 then says, hence find the area of the trapezoid bounded by the x-axis and the y-axis, t1 and t2. So the x-axis, the y-axis, and t1 and t2. So if we want to find the trapezoid bounded by the x-axis, the y-axis, and the two parallel lines, well, we have to basically find where do these lines cut the x-axis and the y-axis so that we can actually zoom in on that shape and draw the trapezoid. So we're going to take the two lines first of all, and we're going to find where do they cut the x-axis and y-axis. So we know that it cuts the x-axis, then what we do is we let y equals 0. And when we want to find where it cuts the y-axis, we let x equals 0. And we're going to do that for the two lines. So our first line was, what did we say? 10x plus y minus 11 equals 0. So 10x plus y minus 11 equals 0. And if I let y equals 0, then that gives me 10x is equal to 11. So x is equal to 11 divided by 10, which is 1.1. So that's out to 1.1 and up to 0. And then if I take 10x plus y minus 11 equals 0, and I let x equals 0 this time, then I get y equals 11. So that's out to 0 and up to 11. And then if I do the same for the second line, well, the second line was 10x plus y minus 1 equals 0. So 10x plus y minus 1 equals 0. And if I let y equals 0, that gives me 10x equals 1. If I divide by 10, I get 0.1. So that's out to 0.1 and up to 0. And then if I do the same for letting x equals 0, then I get y is equal to 1. So that's out to 0 and up to 1. Okay, so what does that look like? Well, if we zoom in on that, we end up with this shape here. And we already know the perpendicular distance between the two parallel lines is 10 root 101 over 101. So, of course, when we're getting the area of a trapezium, our rule is A plus B over 2 times h, where h is the perpendicular height. So we already have h, it's 10 root 101 over 101, which then means that I need my A and my B, right? So my A and my B are the distances between the two parallel lines. So I've marked here C to D and A to B. So if I basically find the length of AB, that's the distance between the 2 points. So it's the square root of x2 minus x1 squared plus y2 minus y1 squared, where my 2 points here are A and B. So 0, 11 and 1.10. So therefore that's my x1, y1, x2, y2. So if I sub in there, that gives me the square root of x2 minus x1 squared plus y2 minus y1 squared. And therefore, if I put that into my calculator, that simplifies to give me 11 root 101 over 10. And then if I do the same for C to D, well, for C to D, my 2 points are 0, 1 and 0.10. So that's x1, y1, x2, y2. So again, if I sub in, I have x2 minus x1, so that's 0.1 squared, plus y2 minus y1, and that's going to be 0 minus 1 to be squared. And again, if I put that into my calculator, that gives me root 101 over 10. So therefore, my area of the trapezium then is going to be A plus B. So that's going to be 11 root 101 over 10 plus root 101 over 10. And I'm dividing by 2 and then multiplying by my perpendicular height, which is 10 root 101 over 101. And that then gives me 6 square units. Okay. And that was the last part of the question.